Hi guys, Gina and I are going to work through 2006 AP Chemistry Free Response Form B question 6. Here we go.
For question 6, part A, you need to draw the Lewis dot structures for each of the 4 specimens. First, you look at the periodic table and you find where GE is in Cl.
Because those are part of the first 2 specimens that we're looking at. Okay, so we see that GE has a valence electron number of 4 and Cl has 7. So we're going to use that to draw our Lewis dot structure. Okay, so we have 1 GE for 4 CLs. So GE is going to go in the middle of our structure, like so. Then we're going to put our CLs on the outside and combine them with a bond.
Now, to figure out how many valence electrons you put around, you have to do an addition problem.
Oh, right. I just said...
you take the amount of electrons that we had figured out 2 seconds ago and
4.
Add 4, and then since there's 4 CLs, you say 4 times 7, and that equals 32.
I can do
So
that.
you put 32 valence electrons around the whole thing.
Well, there should be 32 electrons within this whole structure. So first we're going to satisfy the outside elements. So 1, 2, 3, 4, 5, 6, and then 1 here would be 7. So 1, 2, 3, 4. No, because it's going to be 7 because we need 7 for each CL. And then the other one goes in there. Cool. So now we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And we are done with that specimen. Okay, let's move on to the second one, right?
Yeah. So the next specimen is SeCl4. So when you look at Se, you see that it has 6 valence electrons and Cl has 7 valence electrons. So your addition problem will be a little bit different.
Can you say those again? 6 plus 4 times 7. All right. Again, SC is the least amount, so it's going to go in the middle. And we have 4 CLs, so they're going to go on the outside. We're going to satisfy the outside with the number of valence electrons that they have. Again, 1, 2, 3, 4, 5, 6, 7 for each of these. And then we're going to count them up, see how many we're missing. So 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we're missing 2 more.
And because Se is below, it's on the bottom half of the periodic table, it's allowed to break the octet rule and can have more than 8 valence electrons. So we can put an extra lone pair to make it satisfied.
Only on the selenium, though. Okay. All right, specimen 3. We have 1 iodine for every 4 CLs. Both of them have 7 valence electrons. All right, let's see. That'll be 7. 4 times 7. And we also have this -1 up here, which indicates that we're going to have 1 more electron that's going to be in our structure. So together that's going to be 36 electrons. I is going to go in the middle because we don't have that many of it. And then Cl is going to go on the outside. Oops, that's a crooked. Alright, then we're going to satisfy the outside. We know now that the amount of electrons we have is 32 because we just counted all of them again. But we need 36, which means that we're going to have to add 4 more somewhere. And since iodine is lower on the periodic table, like we just said about selenium, it's going to break the octet rule again. So we're going to add 4 more. And we are done. Except we need to add our parentheses and indicate that it has a -1 charge.
If it ever is not just in its solid state, you have to do the parentheses in plus or minus charge.
Sweet, we're going to see that again. With the okay, so we have 7 plus 4 times 7. And instead of gaining an electron, we're actually losing an electron. So together now we're going to have 34 electrons. It's going to look really similar. A lot of drawing. I think we're going to run out of paper, Gina. Alright, right now we have 32. We need 2 more, so we're just going to add them on in here on the iodine and indicate that it has a positive 1 charge. And we're done with question A.
Woo! Alright, good job, guys. Now, it's time for question B. Ellie can start the problem, and I'm going to get another sheet of paper.
I hope they didn't just see my face. Okay, B. It's asking, what is the Cl-GeCl bond angle in the GeCl4?
Okay, so we're looking at the first specimen in question A, and you see that it has 4 bonding regions, and that means that it is a tetrahedral. And you just have to memorize that tetrahedrals have a bond angle of 109.5 degrees. So that would be the answer to I.
Should we explain why?
Because it's a tetrahedral.
Alright, tetrahedral, 109.5 degrees. Alright, let's try the 2.
I'm ready.
Is SeCl4 polar? Alright, let's figure that out. Here's our SeCl4 specimen. As you can see, it's got 4 Cls, which you would think to be not polar, but there's something special about this little dot pair right there. That lone pair indicates that it's not symmetrical anymore, and anything that's asymmetrical is polar. So, yes, because lone pair
And asymmetrical.
means it's asymmetrical. Yay!
Alright, question I. So it says, what is the hybridization of the I in the ICl4 minus ion? And it's this one. And the hybridization means like the SPDs. So you first have to see how many bonding regions the I has.
Let's count them, Gina.
So, okay, there's 1.
Wait, we should get a different pen.
We're gonna use this. Okay, there's 1, 2, 3, 4, 5, 6.
So the 4 that attach to CLs plus the 2 lone pairs.